All right, welcome to Algebra Cafe. And before we solved systems of equations by graphing, which is this method where we graph both lines and then we find the point of intersection. Now you can imagine that sometimes it's not going to be so easy to tell exactly off the graph where the two lines intersect. And for that we have other ways of solving. And today we're going to be looking at the method in 6.2. This method is called substitution. Let's just look right at an example. Okay, here I've got two equations, and I see here that y is equal to 3x, and then I've got x plus y equals negative 32. So when you do substitution, notice that this is basically telling me that y is the same as 3x. So wherever I see y, I could put a 3x. I'm going to do that right here. So I'm going to rewrite my equation, my second equation, x plus, and in the place of the y, I'm going to write 3x. So here there used to be a y, but y is the same as 3x, so now I've got a 3x here. Okay, why does this help? Well, let's look at this carefully. X plus 3x equals negative 32. Oh, that just means 4x equals negative 32, which means x equals negative 8 if I divide both sides by 4. Now, I'm almost done. X equals negative 8 I can use to find my y value. So remember from up here that y equals 3x. So I'm going to use this, so that y must be 3 times negative 8, and that tells me that y equals negative 24. So now I can write my solution as an ordered pair, negative 8, negative 24. If I want to check to make sure I've got this right, I can plug back into the equation. Y equals 3x. I'm going to check that equation, and I'm also going to check x plus y equals negative 32. This is my x, and this is my y. So I'm going to check to see, is it true that negative 24 equals 3 times negative 8? And I'm going to check to see, is it true that negative 8 plus negative 24 equals negative 32? And that also works, so I know my solution is correct. If I were to graph these two equations, I would see that the two lines intersect at this point, negative 8, negative 24. All right, let's look at a little bit harder example. So this one, we had y equals something else. So you can imagine if it looks like x equals something or y equals something, it's fairly straightforward to substitute, but sometimes it's a little bit more complicated than that. So for instance, let's look at this example where I've got 3y plus 4x equals 14 and negative 2x plus y equals negative 3. So I don't have any y equals this or x equals this in this equation. I'm going to have to solve for a variable. Which one is going to be the easiest to solve for? Well, notice that this y does not have any coefficient. In other words, the coefficient is 1. So getting this y by itself is going to be easier than anything else. I'm going to go for that. So I'm going to add 2x to both sides. And now I've got y equals 2x minus 3. Okay, why does that help me? Well, I can see here that wherever I see a y, I could put a 2x minus 3 in its place. Look back at this equation. 3y plus 4x equals 14. 3y plus 4x equals 14. Now, in the place of my y, I am simply going to put this expression 2x minus 3. Why would I bother to do that? It seems like to make it harder, right? But what's really great is that I have just x's then. So let's go ahead and do it. I'm going to put parentheses before I substitute, and I've got 2x minus 3. All of that just went in the place of the y, plus 4x equals 14. Distributive property here. 6x minus 9 plus 4x equals 14. Like terms, 10x minus 9 equals 14. I'm going to go ahead and add 9 to both sides. I've got 10x equals 23. So that means that x is going to be 23 divided by 10, which is 2.3. Now, don't forget, you're not done yet. You need to go back and plug in to find the y value. So I know that I can use either of these two equations. This one seems simpler. So I know that negative 2x plus y equals negative 3. So that means negative 2 times 2.3 plus y equals negative 3. So negative 4.6 plus y equals negative 3. All right, so my solution, and I'll squeeze it in over here, is this point, 2.3, 1.6. If I want to check, I go back and plug this in, the two equations, to make sure that it works. I could also graph it and see if it looks like it crosses there. I could use the online graphing calculator to give that a try. To recap what we learned about substitution, I just wrote out these steps. Solve for one variable, either x or y, whatever is easiest. Substitute so that you have only one variable, either all x's or all y's. Solve for whatever variable you've got left then, and use that known value to find the other value. So we're going to do that in this example here. Notice in this first equation, solving for x or y wouldn't be that much fun because we'd have to either get everything on one side and divide by 7 to get the x by itself. That would be a pain. Or here we'd have to divide by 2. What's going to be way easier is if you look on this equation, this x is all by itself. In other words, has a coefficient of 1. So that's going to be the easiest thing to solve for. So that's what I'm going to do. All I need to do here is add 1 to both sides. And now I see that x is the same as 2y plus 1. So wherever I see an x, I could simply substitute in 2y plus 1. I'm going to take this equation, 7x minus 2y equals 1, my first equation. And in the place of x, I'm going to put what is exactly the same thing as x, which is this 2y plus 1. So now I've got 7 times 2y plus 1 minus 2y equals 1. Distribute, like terms. Now I have one value, and I can use it to find the other. I can either use this equation, first one, or the second equation. The second one looks easier, so I'm going to use it. 2y equals x minus 1. Now I know y is negative 1/2, so I've got 2 times negative 1/2 equals x minus 1. That gives me a negative 1 equals x minus 1. So I see x equals 0. My solution is 0 for the x-coordinate and negative 1/2 for the y-coordinate. And again, I can check this by graphing, or I can check by plugging in to both of the original equations and making sure it works.